This antenna was called the folded dipole. So how does a folded dipole look like? It is like a dipole. However, the ends, they are connected. Those of you who have seen the television antennas, I had shared a photo. Those of you who have seen television antennas, they might have surely noticed folded dipole antennas. Okay. Have you seen the old television antennas, the Yagi arrays? I told you Yagi arrays. How many of you have actually seen this type of folded dipoles? Anyone? How many of you have seen these folded dipoles or Yagi antennas in real life? Anyone have seen this type of things? Okay, you have seen. Where you have seen you? In our house. Very good. Very good. So you have a television antenna, right? Yagi. Yes, exactly. And did you notice the line that connects the antenna with the TV set? The black colored line. Usually it is black, maybe. No. Then how is the antenna connected with your? Is the antenna connected? Ah, wait. Let me find something. Uh, it was like this. Yes, exactly. I understand that. No problem. When in my house also, no, this type of things are not found. See, this type of things are called twin beam. Okay, these connected the antennas from the TV line. Let me show you some folded controls. See this. This is the folded dipole antenna. Okay, this is the feed. See, this is a basic dipole antenna. This is the other way, and one of the most common, as Leroy had mentioned, this is a Yagi array. I told you once. Okay, this is called reflector, and these three are called directors. This is a folded dipole. Okay, the feed element is the folded dipole. Okay, the reason of why we use folded dipole, the reason why we use folded dipole is this type of folded dipole antennas. They have Z in that is equal to 4 times the impedance of the dipole antenna. Okay. At resonant length, if the impedance is 73 ohms, so the corresponding folded dipole antenna, it will have an input resistance of 73 into 4, that is 292 ohms, and very close to 300 ohms. Right. Now let us see how it is happening. Why the antenna impedance is 300 ohms. We'll try to prove it. So So this is a typical folded dipole antenna, right? What we have discussed. Okay. This is S. This length is L. Okay. And L is lambda by 2. Right. And this is my source. This is my exciting source. Is it okay? This is a typical folded dipole antenna. So its length is L. L is equal to lambda, close to lambda by 2, not exactly lambda by 2. It is at 0 length. Okay. The distance between the two corresponding dipoles is S. Okay. And we assume that S is very small. Is it okay? This is how. So can we write it in this way? The same antenna in this way. Sorry, the lines are not straight. We have to wait for that. But you assume the lines are straight. Actually, they are not so straight. Let me try to follow. Okay, tomorrow, I think tomorrow group B students have their labs. Their lab is over, all the systems, so there will be no labs. And Friday, group A was supposed to have their labs, but Friday is a holiday. So there will be no labs on Friday. Can we write this antenna in this way? This is an AC source, okay? So plus minus doesn't have meaning as such. By plus minus, I am saying over the phase, okay? The plus sources are the same phase, the minus source is marking out. So can we express our antenna into this form? This current is IA by 2. This current is IA by 2. This current is IT. This current is IT. Okay, I will explain the currents in a moment, but just focus on. Yes, it is polarity changed. Why? Because if you add them, see, it must be the same. The sum of these two should be this, right? So if you add them, the polarities are not changed. Okay, polarity are changed. That's why they are cancelling, right? For the second dipole, I want there is no source. Okay, so the polarity is changed. That is why they are cancelling out. You just add up this, you will get the left one, right? Because for second dipole, there is no so external, right? So whatever we assume, it should be equivalent. That is why the right. Any other question? Okay. Now see this one, the first one is called the antenna mode, and the second one is called transmission line. Okay. Can we say here that this green part, can we say that this green part is a short circuited transmission line of length L prime, where L prime is equal to L by 2. Can we say this? say that the green part, okay, is a short circuit transmission line of length L prime, where L prime is equal to L by 2, right? And we have derived the input impedance of a short circuit transmission line in our transmission line lab, right? What is the impedance? Z in was J Z0 tan beta L. Remember, we derived this equation. Okay. So what is IT? IT would be V by 2 into by ZE. This is my first equation. Is it okay? Can we write this for the transmission line part? Right? Is the transmission line part clear? The second equivalent. Any questions regarding that? Okay. Is the second part clear? The transmission line part. Is it okay? Right? So we come to the antenna part. Antenna part. What is this? This is like two antennas, two dipole antennas, right? Both are excited with a similar source. It is like two dipole antennas. So what will be IA? IA by 2, it will be V by 2 by ZD. What is ZD? ZD equal to radiation resistance of dipole. Can we write this? Okay. Can we write this? For each antenna, the voltage at the terminals is V by 2 and the current is IA by 2. So clearly the IA by 2 would be V by 2 by the radiation resistance, right? So we can write that. Is it okay? Is it okay? So what is this current? This current, this current I in, see this one would be I in equal to IA by 2 plus IT. I in equal to IA by 2 plus IT, right? What is I in? I in equal to V by ZFD, or the input impedance of the folded dipole antenna. What is IA by 2? IA by 2 is V by 2ZD. What is IT? IT was V by 2ZD. Sorry, this will be IA. IA equal to V by 2ZD, because the current that is flowing on dipole should be IA. IA should be V by 2ZD, because the current that is flowing from dipole is equal to the input voltage. So this will be IA. So this should be V by 4ZD. Okay. So IA will be this one. So this will be right. So V gets cancelled. So 1 by ZFD, that will be 1 by 4ZD plus 1 by 2Z, that is equal to 4ZD ZD. This will be ZD plus 2ZD 1 by ZFD, right? So ZFD, it will be 4ZD ZD ZD plus 2ZD, or 4ZD 1 plus 2ZD by ZD. Is it okay? Is it okay? Why the current is I by 2? Okay. Because we are taking two parallel dipole antennas. Is it okay? The antenna current is I by 2 because we are taking two parallel dipole antennas. And the current here, the equivalent current of this part is simply IT plus IA by 2. And what is IA? IA was V by 2 by Z. Is it okay? Now see here. Now see here. What is Zin? Zin was JZ0 tan beta L, right? Or JZ0 tan of 2 pi by lambda into L prime, that is JZ0 tan of 2 pi by lambda into L by 2, right? What is L? L is lambda by 2, we are taking half wave. So that is JZ0 tan 2 pi by lambda into lambda by 4, that is JZ0 tan pi by 2, that is infinite. Okay. So Zin is infinite. If Zin is infinite, then this part will become 0. If Zin is infinite, then this part will become 0. So Z folded dipole, that is 4 times of Z. Any questions regarding this? You can see the derivation from the beginning. In equal to Ia plus It. I said Ia by 2 plus It. Okay. So we can just continue with the derivation. Any other questions? Any other questions regarding folded dipole? Scroll towards right. Okay, sure. Uh, okay. Very good. The answer is absolutely no. At least for my exam, it is not required. I know very well because I have been a student like you once, and I will also have to study these formulas. So I do not want you to face the same hardships as I had faced. So you do not have to memorize the big formulas during the exam, right? For example, you do not have to derive the value of radiation resistance for a dipole antenna, lambda by 2 dipole antenna. However, you might be asked the value 73 ohms. Okay, the value you keep remember, but don't have, not pointless. If you want to go, if you are really interested about the subject, if you want to really want to do higher studies in antenna, in field of antenna or radiation, then you should go through the formulas because they are a good introduction. If you are not interested about that, no point in going to the formula. It's just a waste of. Okay. Any other question? Any other question? Okay, why it was I by 2? Because the overall current here, the overall antenna current is IA. Okay, so if we divide it into the two parts, each part will have IA by 2. Any other questions regarding the derivation for anyone who have come late? Some students have come late. If they have anything they don't answer, they can ask. Okay, because we will do with another antenna, and I promise everyone that today is the last class of tough derivations. For the next class, I will try my level best to keep the tough derivations. Today is bear with me. There are some more complaints. Just for today. Okay. Next class onwards, I promise I will try to keep that and more in detail. Acha, anybody who came late, any questions? Didn't understand anything, so I will because then I have to move to the next chapter. Anybody, any questions? Anyone want to ask him? Okay then, we move to the next antenna. The antenna which we are going to do now is called the loop antenna. Anybody has seen a loop antenna? Have anyone of you has seen ever seen a loop antenna? Let me see, I can find something for you. This is a helical antenna, okay? This is what we are going to do next after this one. This antenna, this is called a helical antenna. We will discuss this helical antennas next. Have anyone seen this type of antennas ever? I don't expect you to. Anyone seen this type of antennas in your life? Okay, we will come to this later. Loop antenna. So the loop antennas, they basically named so because they look like a small or large enough. Okay, that's obvious. But let's just get the basics of it. So how does it look? This is our XYZ, and we keep a very small loop, okay, a 2D loop on the somebody is waiting. A 2D loop on the XY plane. The loop is passing a current I. Okay. So the first question is, what is the direction of the flow of current? The question we ask ourselves at the very beginning, what is the direction of the flow of this current? The loop is a perfect circle. Okay. The radius is A. The radius of this loop is A, small a. Okay. So the area is of course pi a square and circumference is 2 pi a. So what is the direction of the flow of current? Okay, we will see later. So the current flowing, once again we will use the same formula AXYZ, and today is the last day of such mathematics. No more difficult mathematics for the next class. So please bear with me for just a minute. I.e. x prime, y prime, z prime, e to the power of jkr by r. Here. This formula we have already seen for the dipole, right? This IE XYZ this can be written as I, Ix, XYZ, J, Iy, XYZ, K, Iz, XYZ. Okay? Okay. Actually, Iz component is 0, as you can see. The loop is on the xy plane, so Iz component is 0. There is no parenthesis on the plane. Right? But for in this type of situations, we often prefer using the cylindrical coordinates for the source points. The formula to convert Ix, Iy, Iz in the expression xyz is dashed, of course. Okay. If you are putting dash in the x, of course, it's better to write dash. You're right. Better to leave dash. Cos phi prime, sin phi prime, 0. Sin phi prime, cos phi prime, 0, 0, 0, 1. I rho, I phi, I z. What is phi and what is phi prime? Phi prime is this point is my rho prime, phi prime. So phi prime is this. Similarly, my observation point is this. So phi is this angle and theta is this angle. So I think it is better if we, I think, okay, listen, this way you will not be able to understand. Let me do attendance, close it for this session. In the second session, I will try to do something different. Okay, this way you will not be able to.